solve the exact equation 2x plus y dx plus x minus 2y dy equals 0. We already know that this equation is exact, so to solve it we need to find the function f of xy whose total differential is 2x plus y dx plus x minus 2y dy. So we need the partial of f with respect to x to equal 2x plus y, and the partial of f with respect to y to equal x minus 2y. Just like we did earlier, to find an initial formula for f of x, we can integrate the partial of f with respect to x, which equals 2x plus y, with respect to x, remembering that our constant of integration will actually be a function of y. So f of xy is the integral of 2x plus y with respect to x, which is x squared plus xy plus some unknown function of y. Now, to make the partial with respect to y match, we can take the partial derivative of the function we just found with respect to y and make it equal to x minus 2y. So taking the partial derivative gives us x plus c prime of y. So we need x plus c prime of y to be equal to x minus 2y, which means that c prime of y equals negative 2y. Now integrate with respect to y to find c of y. So c of y equals negative y squared plus d. So f of xy equals x squared plus xy minus y squared plus d. This is not the final answer because it is not a relationship between x and y. The differential equation says that df equals 0. So we need f of xy to be constant. So we can set x squared plus xy minus y squared plus d equal to 0 to get an implicit solution. Or alternatively, we could ignore the integration constant d and set x squared plus xy minus y squared equal to b, where b is just a different arbitrary constant. Either answer is fine. Also notice that when solving exact equations, you often can't easily solve for y, and often you can't solve for y at all, so implicit solutions are perfectly acceptable.